I'll start recording now, so it's recording. Yeah. No, the 2019.
Okay.
There's a practice test on BitBolite.
Yeah, he posted it like yesterday.
Like, does it actually have like questions, possible questions in it, or is it just like?
Like, remember for the previous two modules, the way he did? It's pretty much the same thing. I haven't gone over the questions though, so.
Okay.
Okay, I don't know what you're talking about, but okay.
Close
Thanks.
You know, for every test, how he posts a summary and like questions, so just that.
Hey, Adam.
Who do you have?
Can we also cover the second fundamental theorem of calculus, where it like you're taking the derivative of an integral, and then you have like a functions in the upper and lower bounds.
Yeah.
And then there's like this weird expression in the center, like which I don't quite understand.
Yeah. He did. The professor who did the Saeed today did the one example like that, but we'll do one as well. We'll do.
Okay.
Yeah, exactly. Yeah, for sure. So I guess I'll write that here. Do FTC with function in both bounds.
Oh, so when you take the derivative and then you subtract them from each other or something like that?
Yeah.
Well, that would be part.
In the session today.
Well, yeah, that would be one of the. I forget which one's part 1, part 2, but yeah. Okay, so let's start with 6.1. So 6.1 is, if I open this up here, is just called area between curves, right? So all that's saying is if I have a function like this and a function like that, and I want to know the area here, right? This area like that, right? This yellow section. If I call this top one f of x, this bottom one g of x, right? And call this the x-axis, right? Or just our well, call it our x-axis. Then that yellow area is equal to this whole integral, right? The whole integral. So f of x, the integral, and I'll call these bounds a and b. So the integral from a to b of f of x dx, right? Minus the integral from a to b of g of x dx, right? So it's kind of like that whole thing minus this section. This can combine, right? You can move the integral to the front. So it's really just the integral from a to b of f of x dx minus g of x dx. And that's our area between a to b. That's this yellow area. So let's just say that, right? And well, that's pretty much it. You can do it on the different axes too, though, right? So that's the difference. And we'll give it a shot. Let's see. Here, how about this? So I'll do an easy one, and then maybe we'll get into harder ones after that. So if R is the region bounded above by the graph of, so the upper bound is f of x equals 9 minus x over 2 squared, and bounded below by g of x equals 6 minus x, find the area of that region. Okay, so we have two things going on. We have a 6 minus x, so that's going to look kind of like that. Okay, and I'll actually call this my thing. So that's my y-axis, my x-axis. So this is our g of x going like this. And I guess that's 6. And then our f of x is going to look something like this. Let's see. So negative 1/2, just call it negative. So it would kind of look like just like that. But like up here, I guess. No, that's not right. At 0. If x is 0, then that's 9. So it would be like there. So it would be like that. Wow. Sorry, bad parabola. Okay, go other way. There. Okay, so we're looking for this region up here. This yellow region like that. Okay? So to do that, we're going to need to figure out what the bounds of the region are, right? We're going to figure out this x value and figure out this x value here. In other words, we're looking for where does this 9 minus x over 2 squared equal the other line, 6 minus x. Right, so where does 3 minus x over 2 squared equal negative x? And then I guess I'll apply the square. So it's going to be 3 minus x squared over 4 plus x equals 0. Just rearrange this a little bit. So it's going to be x squared over 4 minus x minus 3 equals 0. And plugging that into quadratic formula. 1/4, -1, -3. So I get 6, x equals 6, and x equals -2. Someone's got their mic on. Maybe could they? I don't know who's got their mic on. I hear some music or something.
Oh, sorry.
Okay, it's okay. It's all right. There we go. Okay.
Wait, so the 6 and -2 are like your points of intersection, right?
Yeah, exactly. So this would be at that would be at x equals -2. X equals 6. So we know our integral then is going to go from -2 to 6, right? So that's the area that's the range that we're looking at. And we just take the integral of the whole big function, the upper function. Now the upper function is this, so 9 minus x over 2 squared. And we subtract off the integral of the bottom function, which is 6 minus x. So 6 plus x. Well, I'll be more clear. Minus 6 dx. Right, so we set up an integral. Now it's just an integral problem. So I'll just copy that, move it down here. So I will simplify it a little bit. So from -2 to 6 of 9 minus x squared over 4 minus 6 plus x dx. So this will be the integral from -2 to 6 of negative x squared over 4 plus x plus 3 dx. Okay, now I'll take the antiderivative. So it's going to be, this will be -3 over 4 x cubed plus x squared over 2 plus 3x evaluated from -2 to 6. And then we evaluate it at the upper limit. So it's going to be -3 over 4 times 6 cubed plus 6 squared over 2 plus 3 times 6 minus evaluate at the lower limit. So -3 over 4, -2 cubed plus -2 squared over 2 plus 3 times -2. Okay, so this is 36 times 3, or 36 times 6. $214, so 216 I mean, so -200 and, oops, no, -3 over 4 times 216. So -162 plus 36 divided by 2 is 36, 18, yeah, 18 was right. See, I did it. Plus 18, okay, minus, again, okay.
Use your lasso, select it all, press math, and press evaluate.
I don't think it'll like my writing. We'll see what happens.
Okay.
Yeah,
So
but let's.
First one I got -126.
-126? Yeah, it looks like I'll get the same thing, yeah.
Bracket.
Let's see what it'll do. Well, actually, no, did it actually get it?
I think you got it. It looks like it got it.
So,
yeah, it did.
action, evaluate, -128.
Is that the answer?
Okay, let's see. No, that's not the answer. That's,
Okay, I think I did something wrong there. Okay.
negative, let's see, is my antiderivative right? 6 -2, 3x minus, oh yeah, my antiderivative, hold on. No, then there's something wrong with that, what I did. Hold on. 3x. Oh. I did, wait. Oh, I multiplied by 3 instead of dividing by 3. Okay, there's the problem. Here. I multiplied by 3. I was supposed to divide by 3. There's the problem. Okay. So that's a 12. So that's a 6 cubed over 12. And this is a negative 2 cubed over 12. And now let's see if it gets it. Lasso. Hope I got everything there. No, it did not get everything. Hold on. Okay. Math. Yeah, no, I did not like that. No. that time, for some reason, my writing got worse there, I guess, or I don't know what happened. Okay. Well, you know what? I'm just going to punch this whole expression into my calculator. So let's just see what it says. So negative, negative 6 cubed over 12 plus 36 over 2 plus 18 minus negative 2 cubed over 12 plus negative 2 squared over 2 plus negative 6. Okay, I got 64 over 3, which is the right answer. Okay. 64 over 3, which is correct. That's the area under the curve. Okay, so there's that question. Let's do an example where they cross in the bound. Yeah, here. Okay, so let's do this example. Yeah. So, oh, it doesn't give the functions? That's the thing? Okay, then I can't do that. Hold on. Just want to find a good example. Okay, let's do a different one then. Does anybody have a suggestion from the practice problems of 6.1? Okay, let's do maybe quickly just one here. That looks too hard. What are the suggested problems for 6.1? Goes up to 36.
I got one.
Yeah.
So the first function is sine x.
So y equals sine x.
Yeah, y equals sine x.
Okay.
Then we got y equals cos x. And then we have two vertical lines. So x equals pi over 4. And x equals 5 pi over 4.
5 pi over 4. Okay, I think I remember doing this, but this was 0, but it should be similar. So yeah, okay. So let's see here. So let's draw. That's our cosine graph. 5 pi over 4 is less than 2 pi. Yeah, it's 1 pi over 4. Wait, no. 3 pi over 4 is okay. Whatever. Less than 2 pi. So I don't know exactly where it'll be, but we'll see. So then our sine graph is going to look like this. No, not like that. It's going to look like this. Hold on. Can I draw a sine? Yeah, that's what it looks like, I think. Looks about right to me. Should be a little higher, actually, but so I guess I'll draw it a little bit better. So it looks like it should be like that. There. Okay. So that's our sine x. That's our cos x. Pi over 4, I'm almost certain is where they intersect here. Right? So that's x equals pi over 4. We can check that, but I'm pretty sure that's right. And then 5 pi over 4, is that where they intersect again? Is that this right here? Let's see. Is cos of 5 pi over 4 divided by sine of 5 pi over 4. Yes, so that's where they intersect again. Like this. So that's 5 pi, or x equals 5 pi over 4. So we're just looking for this integral here. Well, all that is we're looking for, oh, well, this is also the x-axis, right? So, okay, then we need to do this, we just take the, okay, well, we're going from here to here, so this is our bounds on the integral are going to be from pi over 4 to 5 pi over 4. And it's going to be the upper function minus the lower function. So the upper function is cos x minus sine x. Did that backwards. Upper function is sine x minus cos x dx. Right? And yeah, okay, that should work. Okay. So if I take the antiderivative, well, the antiderivative of sine, derivative of negative cos is sine, so negative cos x, and the derivative of negative sine is cos x. So negative cos x, negative sine x is, oh no, I did that backwards. No, and the derivative of, yeah, that's right, never mind. From pi over 4 to 5 pi over 4. And so I evaluate it at, so it's negative cos of 5 pi over 4 minus sine. It'll be 0. Is the answer 0? Is that the answer? Just to see if I'm on the right track? Is the answer, if the person...
So here's the deal. I was supposed to do this after the lecture ended, right? Because like the way I do it is like I'll take the example, I'll write like I'll get it set up, but I'll do the computation later. But then I forgot. But you're probably right.
I think it's 0 because, well, look, I mean, my math is going to end up with 0 here. I'll show you why, right? So, well, we know that they intersect at these points, so we know they're equal, right? Oh, never mind. Sorry. Then I was thinking too far ahead. Yeah, it's actually not the same. Never mind. It's not the same thing. So negative cos of negative cos of 5 pi over 4 minus sine pi over 4 would be root 2. So this is root 2 minus, I think root 2 again? No, that doesn't make sense. Just pi over 4? Yeah.
Isn't it root 2 over 2?
So I think what's going to happen, now I kind of did, I did a little bit of math in my head, but I think, so cos of 5 pi over 4 is negative root 2 over 2, right?
Yeah.
And negative, and sine will be the same value, right? So negative root 2.
Sine is positive in the second quadrant.
Did I?
Like 5 pi over 4 is in the second quadrant. It's C8ST, so second quadrant has sine positive, right? So it should be negative just. C-A-S-T. 5 pi over 4 is like that, so sine should be positive. But I type in sine pi over 4 and I get negative root 2 over 2. The calculator is messed up because the calculator doesn't. Like I had the same issue with my calculator, but apparently your calculator is horrible at knowing like the different quadrants other than the first quadrant. It'll usually only give you values in the first and fourth quadrant. For some reason, it just programmed like that.
Oh. But also looking at the graph, let me put here.
It should be positive.
Sine x, cos x, x equals 5 pi over 4. They're both negative. They're both negative at that point. Oh, I'm in radians. Yeah, I'm in radians.
Yeah, it's in quadrant 3, right? 5 pi over 4. So they're both negative.
Oh, I'm being stupid. Okay, yeah, it's in quadrant 4. Okay, wait, C.
Quadrant 3. Yeah, quadrant 3. Okay, yeah.
Quadrant 3. Okay.
I'm being being stupid. I thought it was in quadrant 2.
Yeah, and I also was thinking it was in quadrant 2. You're right. Yeah, but so there we go. So it's in quadrant 4. Yeah, so they're both negative. They're both negative. So then this is going to combine into just root 2 over 2 plus root 2 over 2, which is equal to 2 root 2 over 2, which is equal to root 2.
Gotcha.
So that's why I just wrote root 2 here, right? And this will be the same thing, I'm pretty sure, if they have the same value. Oh, well, there's that. If I go here, no, but it'll be positive. Oh, I guess it'll still be positive. Well, let's just do it. Let's just actually type it in. So minus negative cos pi over 4 minus sine of pi over 4 is, again, root 2. So it's just plus root 2. So 2 root 2 is the answer. Okay.
Hey Adam, could you go up a little bit on the top? Just yeah, I didn't catch the on top of it again, because I can't really see it. Thank you.
There you go.
Thanks.
No problem.
Wait, I'm kind of bad at reducing. So I used like 1 over root 2, right? And I got 4 over root 2. How do I reduce that?
4 over root 2?
Yeah, if it's 4 over root 2, then I get 4 root 2, right?
Not quite. Not quite. So you're multiplying the top and bottom by root 2, right? So the top is going to turn into 4 root 2 over root 2 times root 2 is 2.
Oh,
which is
okay.
2 root 2.
I just thought it was 1.
Yeah, don't worry. No, yeah. So exactly. So that's root 2 over 2. I mean, root 2 times root 2 is 2.
Thank you.
Nope.
Where is this problem from?
I'm not sure. Someone just said it in the chat, or said it in the.
It was from Charles's lectures. Kim Charles.
Wait, from whose lecture?
Kim Charles. Like, it's one of the professors.
Oh.
Okay, so then anything else from 6.1? Because there's other problems, but we also have 6.2 and 6.3 to do as well. So there's a lot in there. So we use the same ideas. Any other suggestions from 6.1? The only thing that would make it more complicated is if they intersect somewhere, but I want to find an actual example where they intersect. Or how about we do this one, number 3? Just because, or number 6. Yeah, let's do number 6. So number 6 from the textbook is y equals x. So I assume it's for the following curve, split the region. Yes. So y equals x equals y squared. And yeah. So if I draw a graph of this, right, so I can rearrange this one into y equals root x. And so we have two graphs. We have a straight line, and we have root x, which is going to look like this. And so we're trying to find this area in there. They intersect here. They intersect. Oh, no, sorry. These aren't intersecting, and we have to find more areas. All right, I'll do a different example. They intersect, but you don't find the area past the intersection. So y equals x cubed, and y equals x squared plus x, and we're trying to find the area between these curves, between these two curves. So first of all, y equals x cubed is going to look like that, and x squared plus x is going to look like this. And they both intersect at 0. Okay, so we're looking for the area between these curves. Oh, sorry, and this I didn't see, but well, actually, let's look at this. So it looks like it'll just be this. It looks like it'll just be this, right? Let's figure out what this intersection point is here, though, right? So this is 0, 0. That's 0, 0. Let's figure out what that intersection point is. So it'll be 3. Oops. We're gonna set x cubed equal to x squared plus x. We can divide everything by 0. Divide everything by, not by 0. Divide everything by x, so that means we have a solution at 0, right? So x squared equals x plus 1, okay? And then, well, we have a quadratic now. X squared minus x minus 1 equals 0, right? So it will, and the solutions to this are, this is the one that has the solutions which are the golden ratio. So, I remember doing this before. So, it doesn't have nice solutions. 1, negative 1, negative 1. So, the two solutions are x equals 1 plus root 5 over 2, and the other solution is 1 minus root 5 over 2. And again, this is the golden ratio, which is, I think, written like that. But yeah, so that's just a different thing entirely. But but the one thing to notice out of this is we'll just take the decimal form of it, right? We'll take the decimal form. But so this is going to be our negative root, 1 minus root 5 over 2, right? But they actually intersect again, way up here. So I'm going to kind of draw it poorly, but they intersect again. So we're actually finding this area, this all the yellow area that you see here. But it's just two integrals. So we're taking this area, which is going to be the integral from 0, oh, sorry, not from 0, from 1 minus root 5 over 2 to 0 of the upper function, x cubed, minus the lower function, x squared plus x, dx. And then this area here is going to be another integral. It's going to be the integral from 0 to 1 plus root 5 over 2 of the upper function. So the upper function is x squared plus x minus the lower function, x cubed dx. And then we just evaluate these two integrals and then put them together. Right? So to evaluate this one now, I'm kind of getting messy, so I'll just put that like that. So I'm going to take the antiderivative, so x to the 4 over 4. This is negative x squared, so negative x cubed over 3. This is negative x, so negative x squared over 2, evaluated from 0, well, from 1 minus root 5 over 2 to 0. So the actual number this is equal to is going to be this here. So I'll just say alpha equals 1 minus root 5 over 2, because I don't want to write that over and over again. So alpha to the power of 4 over 4 minus alpha to the power of 3 over 3 minus alpha to the power of 2 over 2. Not evaluated, just that. And it's the negative of this, right? Because we're taking the lower limit. Right? It's this minus this. So evaluated at 0, it would all be 0. So it's just negative of the bottom one. Right? And well, that's our first area, right? That's which area did I just do? Oh, I did this big area for some reason. That was my first go. And then the next area will be this stuff here, right? So yeah. So this integral is the integral from 0 to 1 plus root 5 over 2 of x squared plus x minus x cubed dx. And so the integral is x cubed over 3 plus x squared over 2 minus x to the 4 over 4, evaluated from 1 plus root 5 over 2 to 0. So again, alpha equals 1, or I shouldn't call it alpha now. Beta equals 1 plus root 5 over 2. So this is beta cubed over 3, beta plus beta squared over 2 minus beta to the 4 over 4. That. So it's that minus that. I'll punch it in. It'll just be a lot of typing in. So I might just not do it. But the answer is going to be the two areas combined, right? It's going to be this area, this area, just the area of the
But
first.
why is it negative? The first area.
Because, well, most likely this is going to end up being, I mean, hopefully this number is going to end up being a negative number, so the actual area will be positive. But the reason there's a negative sign in the front is because it's the upper limit minus the lower limit. So it's really the upper limit. This evaluated 0 is just 0, minus it evaluated at 1 minus root 5 over 2.
Yeah.
So it's that minus that. There. So that will be your answer. Beta is the negative root, alpha is the positive root. And yeah. Like if someone wants me to type it in, I'll type it in. It's just gonna be a lot of typing in, so I think maybe it's worth our time to just keep going. The main thing to learn from this is you got to separate your intervals. So whenever they intersect, it's a separate interval. And also, don't like your graph is can be a rough graph because just make sure you know where they intersect. So we checked for this one. We discovered that there's another intersection point. So we're actually talking about this whole section. Okay, so that's 6.1. That's pretty much all I wanted to say there. 6.2 is determining volumes by slicing, but not just slicing. So 6.2 is, well, I'll call it slicing, disc, and washer method. So, but this to determine volume, or it should be a capital D. Determine.
Do you guys know if we ever have to integrate an absolute function?
Well, you might, and in that case, if you're doing a definite integral of the absolute value function, then you know if it should be negative x or x. Right, because the absolute value function is defined as negative x if x is less than 0 and x if x is greater than 0.
Mm-hmm.
So at that point you just say, okay, well, if the range I'm looking at is negative, then I'll just take negative x. You can just choose which one it is for absolute value.
Okay.
And if it crosses over, then you have to split your integral at that point where it crosses over. Like where it crosses over 0.
Yeah.
You have to split your integral there. Yeah. So that's that. Okay, so these are methods for solving for the volume of a shape, right? So I think let's do one thing that I think is just kind of cool that we can do is slicing apparently is not on the test. I don't know details much about that, but I think there won't be a slight, as far as I've heard from people I'm talking to, slicing is not going to be on the test, but definitely is a good way to think about this kind of stuff. So I think I'll do one slicing problem, and we'll see how it goes. The problem is actually just kind of like a fun thing to do. So it's determine or derive. I'll type it. So derive the formula for the volume of a sphere. Okay. So to do this, well, we have a sphere centered at 0, 0, right? A cross section of it would kind of look like this, right? So this is that's our y-axis, that's our x-axis, right? So a cross section would look like that if it's centered at 0, 0. It's defined as x squared plus y squared equals r squared, right? Where r is the radius. Well, r is the radius. So what we can do to determine the formula is, determine the formula for the volume of a sphere is, you take each slice, right? You take each slice and integrate them all together, right? And, well, of course, now I'm forgetting how to do this. Hold on, let's see if it's written here. No, it's not, because I remember circular cone. Okay, I did this before. Let me think. By slicing, we know
You have
that's...
used the definition of the integral, right? Technically.
Well, we'd be... Okay, yeah, here, I think I understand now. Okay, you take the area of each... So the slicing method is pretty much saying we have a whole 3D shape. I don't know how to draw it. That's a 3D. I don't know. That's not 3D. But we have a whole 3D shape, and it's made up of a bunch of slices of 2D shapes, right? Infinitely many slices of 2D shapes. So you integrate it across the whole thing, right? So each of the, if we were to take slices going like this, they would each look like circles, the cross sections, right? So the area of each of those cross sections, okay, so the area of the circle of each of those cross sections is pi r squared, right? And the radius at that point, right? The radius is going to be, we can define it like this: is the radius is going to be the square root x squared plus y squared equals r. I swear I could do this before, and now I'm drawing a blank. Does anybody?
Maybe draw a semicircle on the x-axis and then rotate it around the x-axis. Then you can probably get something from there.
Yeah, take this semicircle and rotate it around the axis. Yeah.
Yeah, so just take the semicircle and then rotate out.
But how do you define? How do you define?
You can.
Okay, yeah, just the
the
semicircle.
disk method. Yeah, so we can use the disk method with the radius, right? With the top and bottom, then integrate.
But the radius is in terms of. Oh, the radius is the y value. The radius is the y value. So we just say yeah. There we go. That's the trick. Okay, so x squared minus, or r squared minus x squared equals y squared, right? So y is going to equal the square root of r squared minus x squared, and that's going to be the radius of each of these circles, right? Of each of these circles. If I take the slice like this, right, the radius of each of those cross sections is going to be the y value, right? So if the radius of one circle is pi r squared, the radius of all those circles are pi times this squared, so it's r squared minus x squared, where r is the radius of the whole sphere, right? This r is the radius of the whole sphere. And we want to integrate this from negative r to r. Yeah, dx. Yep. Okay, so I can pull out the pi to the front. So it's the integral from negative r to r of r squared minus x squared dx. Okay. And then integrate this with respect to x. This is going to be pi times r squared x minus x cubed over 3. Okay, r squared x minus x cubed over 3. Evaluated from negative r to r. So let's see what happens. Okay, so evaluated r is going to be pi times r cubed minus r cubed over 3. Square bracket, I guess. Minus evaluated negative r, well, it's going to be negative r cubed plus r cubed over 3. And is this going to end up how I want it to be? Let's see. Pi times, so it's going to be r cubed plus r cubed, negative r cubed over 3 minus r cubed over 3. So this is going to be pi times 2r cubed minus 2 over 3 r cubed, r cubed. That's it. Then
factor out the r cubed.
Factor out the r cubed, yes. Pi r cubed. 2 minus 2 over 3, yes.
4 over 3, I think it is?
Yeah. Negative?
No positive.
Oh, 1/3. One third, yeah. Yeah. Oh no, 4/3, sorry, yeah, sorry. So times 4 over 3, and that's the formula. 4.
Yeah, we did it.
Pi r cubed. There we go. That took more brain power than I expected it to. Okay, yeah. So there you go. 4 over 3 pi r cubed. That's the formula for the volume of a sphere. We did that by taking a semicircle, not the whole circle, a semicircle, and then taking cross sections, right? Well, really, we took the whole. Sorry, that was kind of no. We did take the whole circle. It was just easier to look at as a semicircle, but we did take the whole circle. Oops. Right. Of a circle of radius r, or a sphere of radius r, took the cross sections and integrated them all together. So each cross section had an area of pi r squared, where r, like, so the r of this circle is this. The r of this circle is this height, right? That's the r of that cross section. The r is that height. Oh god, I keep clicking erase by accident. And so that would be the radius. So the radius squared is that, integrated from negative r to r. And so there's our formula. 4 over 3 pi r cubed. Okay, so I guess that's kind of that was actually the disk method. I guess that's what it was. Well, not really of a function, but of a shape, right? So it's kind of similar to slicing. We could also do a cone. I think let's do a cone. 'Cause cone wasn't too bad. So let's see how well this goes, but derive the formula for a cone. So let's set up our cone like this. It's on the x-axis. It looks like that, and so that's our y-axis. That's our x-axis. Okay. It has a entire height of h, right? It has a height of h, and has a radius of big R. Okay. Big R. And I'm taking a cross section like that. The cross section has a depth of x, right, and a radius of little r. So we want to integrate all the cross sections from 0 to h, right? And so we want to take the area of each slice. So the area of each slice is going to be a circle of radius r, because this is a cone, right? I can't really draw a cone, but well, I guess I make it a circle on the bottom. So the cross section will also be a circle. The cross section will also be a circle of radius little r. This is radius big R, right? So that circle there is going to have an area of pi r squared. So I need an expression, right? I need an expression for that radius in terms of x, because we're integrating across x, right? So I can use just the ratios here, right? So big R to h equals little r to x. I can rearrange this for r. So r equals big R x over h, right? And so now I can plug that into here. So the area of one piece is pi big R squared x squared over h squared dx. And so I'm going to take that integral. I'm going to pull the pi out to the front. I'm going to take that integral from 0 to h. And, well, I can actually just integrate now, right? All these things are constants. These things are all constants here. So it's just going up by, the power is going up by 3. So it's going to be pi. Oh, pi is not there anymore. I think I actually could have taken out, I think I can actually take out r squared over h too. Yeah. And so all that's left is inside is x squared dx, right? Oh, so that's h squared there. X squared dx, so it's going to be x cubed over 3 evaluated from h to 0, or 0 to h. So 0 is nothing, right? So h is going to be pi r squared over h squared times h cubed over 3. These cancel. So it's 1 over 3 pi r squared h, which is the formula for a cone. Yes, there we go. That worked better for the volume of a cone, where r is the radius of the base, right? 1 over 3 pi r squared h. So there we go. I think that's really cool that we can get the volume of these shapes now. It's like a cool thing that we can do. So derive the formula for the volume of a sphere, cone, cylinder is pretty simple. I've done a pyramid, the triangle-based, square-based pyramid, very similar to this square-based pyramid. And yeah, so that's that. Let's move on, I guess. So I can do, we have shapes which are called solids of revolution, right? I guess the best way to show it is just show a picture, because I cannot draw. We have an area rotated around the x-axis, you get a solid of revolution, right? You get this kind of thing like that. And so the question is pretty quickly, how do you find the volume of that shape? Right? So one way to do it is you take something like this. No, I can't really draw on here. Here, how about I just draw it here? Right? You have your, let's say your function root x, right? That's root x. And we want to find the solid of revolution, right? That goes from A to B. So it would spin around like that, right? You get a shape like that. And the way we do it is we just break it into disks, right? And integrate those disks from A to B. So, for example, let's do this one. Let's do root x, right? From 0 to, well, what's the nice thing that has root 9, I guess. So there you go, right? So if this is 0, 0 to 9, right? We're going to integrate from 0 to 9. And each sphere, right? So what's each sphere? We're going to add up all those areas. So each sphere will have an area of pi r squared. And the value of r at that point is just the distance. It's just root x, right? So r equals root x. So pi r squared is going to be pi root x dx. Move that pi to the front. 0 to 9. Root x dx. Squared is just going to be x. Because it's r squared. So it's just x there. I don't know why I wrote root x though. And so now to integrate this, we just say pi times x squared over 2 evaluated from 0 to 9. Right? And then so we just evaluate this, right? So it's just the upper limits is going to be pi, so 81 pi over 2. So that's the volume of this shape. The rotated solid, what is it called? Rotated solid, solid of revolution, right? That's comes from revolving root x around the x-axis. Okay. So, okay. There's, of course, also the washer method, right? So the washer method is if you have something like this, right? So if we're trying to, let's say, revolve, let's just stick with root x. So, because root x is just a nice one. So we're still trying to revolve root x to make a cylindrical, not a cylindrical shell, but to make a volume, a solid of revolution or whatever it's called. But we're going to revolve around x equals 1, or y equals 1. There, y equals 1. Y equals 1. And that's root x. So now, when I revolve this, it's going to have a gap in the middle here, right? It's going to have a big gap like that. So essentially what we do is we take the whole solid that gets created, the volume of that, and subtract the volume of this that we get created there. So the volume of the whole solid won't change. The volume of the solid will still be, we can even just, let's say we're still going to 9. Or, yeah, let's just say we're still going to 9. So the volume of the whole solid will still be 81 pi over 2. But I need to subtract the volume of the inside there, right? So just to be a little clearer, I'll do it actually from the beginning, but maybe we'll skip this stuff. So the volume of the whole thing, right? The volume of the whole thing is going to be the integral from 0 to 9 of, similar before, is going to be pi r squared. But r, for any of these cross sections, is going to be root x. So it's going to be pi x dx. And we want to subtract the integral from 0 to 9 of this bit in the center. So any circle in here is going to have just a radius of 1, because y equals 1, right? For all the circles here, it's going to have a radius of 1. Right? So it's going to be pi 1 squared, so just pi dx. Right? So now we can do this. We can factor out the pi, of course. So pi out of both of them. So it's going to be pi times the integral, that's an f, the integral from 0 to 9 pi x dx minus integral from 0 to 9 of pi dx. Oh, no, I said factor out the pi, didn't I? So 1 dx. And now we can also combine the integral signs. So it's just pi times the integral from 0 to 9 of x minus 1 dx. And so in general, the formula is if you have a upper radius and a lower radius, it's going to be pi times the integral from a to b, right, from where you're starting to where you're going, of the upper radius squared, right, so bigger radius squared minus the lower radius squared dx. So we did that. We did that here. Upper radius was root x. Root x squared is x. Lower radius was 1. 1 squared is 1. Right? So there's that. That's our rule. And now I'll just evaluate this integral. So to evaluate this integral, it'll be pi times x squared over 2 minus x evaluated from 0 to 9. So it's going to be pi times, so this is again 81 over 2. That's what I said before, right? It's the original volume minus 9. Okay? So it'll be 81 minus 9. 81 over 2. So 63 over 2. So 63 pi over 2. And there you go. Yeah. 63 pi over 2. And that's the volume of root x. Oh, sorry. Wait, hold on. Did I say that wrong? We revolved. Okay, hold on. I may have explained that wrong. So we revolved around the x-axis still. Sorry. We revolved around the x-axis still.
Okay, that's why I was so confused.
Yeah, sorry. I said that wrong. Yeah, so I kind of screwed that up. Sorry. I guess I'm having just a difficult time today for some reason. Revolve around the x-axis still. You can't revolve around something that is inside your thing. Oh, someone's at the door. Sorry, 1 second. So yeah, sorry. You're not revolving around. You're revolving around the x-axis still, but you want the region. You want the region enclosed by root x and y equals 1 and x equals 9. So pretty much the question would have asked the region bounded by root x, y equals 1, x equals 9, right? Revolved around the x-axis. This is how you would do that. So you need to take away the inner radius, just use the upper radius. And yeah. So I totally phrased that wrong before and was incorrect. So sorry. But yeah. Okay, so there's that. I'm gonna open the window quickly because it's hot in here. Don't know how. So, okay, anybody have any questions from 6.2? So do like practice problems for us to do.
This was the washer method, right?
This was the washer method, yeah.
So basically the washer method is just like the disk method, but you just have to minus like another r squared, essentially,
well,
right?
You have another volume inside that you have to take away.
Okay, good. Right. Thank you.
Yeah, no problem. Maybe let's do a more complicated washer method with actual like 2 different functions. Okay, what about this one? This one's pretty good. So we want to find the volume of the solid of revolution formed by revolving the region bounded above by f of x equals 4 minus x, and below, it's bounded below by the x-axis, or by y equals 0, but rotate around y equals -2. rotate around y equals negative 2. Yeah. So this is kind of what I was meaning to say, but I just said it like I mixed up two examples. So what if you're rotating around something else, not the x-axis, and it's also not in your piece, in your region, right? So let's graph these two things. So negative x plus 4 is going to look like this. Y equals 0 is, of course, like that, right? So we have kind of a thing like that. And so this is going to be 4. This is going to be 0, negative 4. Wait, hold on. 0 equals 4 minus x. So x equals 4. Yeah. So this is going to be 4. That makes sense. I didn't thought too hard about that. So we're looking for this region, right? This region like this, but revolved not around the x-axis, revolved around y equals negative 2. Try it a little lower, just so it's a little clearer. Y equals negative 2. Yeah. Good. So now we're not revolving around the x-axis. So if I were to just revolve this, like this whole thing, it would give me this whole yellow section, right? Just this whole integral. It would give me this whole yellow section, but we don't want that. We want just that bounded area. So to do that, we would take the revolved solid of this whole thing, right? This whole thing, minus this middle bit in here, right? Minus this middle bit in there. So, you know, if you were to see this revolved, it would look like something like that, right? Well, okay, didn't work that well. It would have like another circle like that, and this is like on an angle. I don't know. Anyways, but so that's what actually, you know what? I'll just put a picture here. That's what it would look like. So there's our triangle. It's revolved around here. This is like an empty cone in the middle there. You see, empty cone. Okay. So let's find the, so this is going to be pi times the integral from 0 to where? 0 to 4. Yeah, 0, but never mind. Sorry, 0 to 4. Yeah, obviously, because that's where the thing ends. 0 to 4 of the upper radius, which is 4 minus x, so, or x minus 4, sorry. No, 4 minus x. 4 minus x minus the lower radius. And the lower radius is just going to be 2. Right? Because this distance is 2. Right? Oh, and sorry, the upper radius is not going to be 4. Wow. Not on my game today, sorry. What is this distance? What's this radius? Well, it's 2 plus 4 minus x. Right? 2 plus 4 minus x. So, 2 plus 4 minus x minus 2 plus 2. Oh, minus 2. Because we're subtracting this radius here. Dx. So these will cancel. So it's pi from 0.
Isn't it squared though?
Yes,
or
it
no?
is. Sorry guys, I don't know what's going on with me today. Yeah, not on my A game. This is the radius squared minus that other radius squared, because we're finding the area of the cross sections here. Yeah. So I can combine this over here. So it's 6 minus x squared minus 4 dx. That's right. And then I'm going to take this integral like that and expand this a little bit, right? So 6 times 6 is 36 minus 2 times 6x, so minus 12x plus x squared minus 4 dx, right? And then I'll just evaluate 0 to 4. That's going to be x squared minus 12x minus 32 dx. And then pi, I can just evaluate now. So x cubed over 3 minus 6x squared minus 32, evaluated from 0 to 4. So pi times 4 cubed over 3 minus 6 times 4 squared minus 32. and that will be your answer. Pi times 4 cubed over 3 minus 6 times 4 squared over nothing, over 1, minus 32. And I got a negative area, negative 320 over 3 pi. So, assuming that the number is right,
it should be positive 30.
It should be positive, yeah, for sure, right?
Like the 32.
But 32?
36.
Isn't it supposed to be 32x?
Yeah, because it's 36 minus 4.
Yeah, yeah, there's supposed to be an x there. It's supposed to be an x there.
Okay.
Yeah. So then this is going to be 32 times 4, and I still don't get the answer. So I still get, wait, did I?
No,
It's supposed to be
like
positive 32.
Yeah, like the 32 is positive. Because it's positive 36 minus 4.
Yes, that's correct.
Right.
Yeah.
Yeah.
So positive, so I get 160 pi over 3. And that's the answer. Okay. So there's that. I'd say let's move on to 6.3, but of course, unless someone has more questions about this stuff, let's move on to 6.3. I haven't done any 6.3 practice, although I have done some of the cylindrical shells, like I just tried it for a different question, so. Oops. Let's pull water on the tablet. So, I have to wipe it with something. Just wipe it with this. So, yeah, does anybody have any questions for 6.2 left? So yeah, then let's talk about 6.3 again. I have not done 6.3 practice, so the questions might be a little, well, we'll see. We'll see how it goes. So I know I am behind on the practice. So 6.3 is the method of cylindrical shells. So if I'm determining a volume like this, so again, let's do our root x because root x is nice, right? So let's say I want to find, and this is where I'm ending. Let's say I want to find the volume of this rotated around the y-axis, right? Y-axis. One way to look at it is that let's choose any one line. Choose any one line here, right? And if that were to be rotated around the y-axis, it would create a cylindrical shell, which is pretty much just a cylinder, but without the inside. It would create a cylindrical shell. It's a terrible picture, but there you go. And if we took pretty much the surface area of each of these cylindrical shells, right, and integrated that along A to B, we'd get the volume. We'd get the new volume, right? So let's try that. So if I have root x, and I'm going to 9, and I have I'm revolving around the, let me try to draw this better. So if I have my y-axis and my x-axis, I have root x to x equals 9, and I'm revolving around the y-axis, then I can take just the cylindrical shell at this point here, right? And so what would the height and what would the radius of that cylindrical shell be, right? So the height would be the value of the function, right? So first of all, the surface area of a cylinder, of a cylindrical shell, is the circumference, right? Circumference times the height. So 2 pi RH is the surface area of the cylindrical shell. Oh, someone's home. Probably have to answer the door in a second too. And then, so to find it for this particular one, well, the height would be the value of the function, which is root x, right? So the height would be root x, right? And the radius would be the distance that it is away, which is just x. So it's 2 pi x root x in this case. And what we're going to do is we're going to integrate 2 pi x root x from 0 to 9. Yeah, that looks like it should do it. We can take out the 2 pi from 0 to 9. We just have x root x, which is just x to the 3/2. Right? And let me just make sure I see the formula here, just to make sure I'm doing it right, but it should be correct. Hopefully someone also knows. Yeah, 2 pi x root x. Yep, good, we're good. So now I can integrate this, right? So 2 pi, take the antiderivative, so it's going to be x to the 6 over 2, so to the x cubed over 3. Right? No, 5 over 2. I'm adding 2. Yeah, 5 over 2. 2 over 5. Like that. I'll write that nicer. X to the 5/2 times 2 over 5. Evaluated from 0 to 9. So let's just do that. Evaluate at 9. So 2 pi times 2 over 5 times 9 to the 5/2. So 2 pi times 2 over 5 times 9 to the 5/2. And I get some big number. Some, yeah. 2, well, not big, but some rational. 2,434 over 5 pi. Right? So, yeah, and so that would be the rotated solid that goes around the y-axis, right? So these functions are all defined y equals something, right? So this was y equals root x, right? So they're defined in terms of x, but we're rotating around y-axis. So this is a slight difference there, right? It's just like, that's the criteria. And then in general, so what we did is we did 2 pi x is going to always be the same. And so in general, the answer to this kind of question is going to be the volume of that kind of solid is the integral from a to b of, 2 pi times the integral of from a to b of x f of x dx, right? And so that's what we did. F of x was just root x, right? And x times that. So the x is always going to be that because the radius of every cylinder is just going to be x because it's just going to be that distance away. And the height of every cylinder is going to be the value of the function at that point. So yeah.
I have a question.
Yeah.
Sometimes they do like x minus like 2 or x minus 3, depending on the question. Like when would you have to do that? Like when would you have to account for shift? Is essentially what I'm asking.
X minus 2 as in like okay, that's
like
what I'm
for like.
mm-hmm.
I don't have an example like on the top of my head, but like in the lectures they would do like x minus 2 to account for some shift, and like I forgot.
Yeah.
What?
That's when the rotation, axis of rotation is not y or x axis.
Or I think, or what I'm drawing here is if you're farther away from the x or y axis, like
yeah,
you're not
something like that. Yeah.
Right. So this would be, let's just say root x. It would be root x minus 1. I guess let's just call that. Yeah. So this would be 1. So let's say we're still doing the same idea, but we're rotating around that now. We're rotating around that area. So we're going to ask the same question. If I just take some cylinder that's going to appear from here, what's the height and what's the radius of that cylinder? Well, the radius of that cylinder is going to be, let's see, what's the radius of that cylinder going to be? Oh, it's still going to be x, isn't it? That's where I was going to think it's going to be different, but it's still going to be x, right? And so if we take our formula, so the volume is going to be 2 pi from a to b of x f of x dx. Then we have that f of x is still, so the height, if I just trying to imagine a cylinder, right? So yeah, its radius would still be x. And you just integrate from 1 to this. Okay, so that's not an example because we just do the same thing here. We would just do the same thing here.
Shouldn't it be like 1 plus x?
but the x value is 1 plus, like, this is still the x value, right?
You have to do y. It doesn't work if you don't do it in terms of y. I guess.
Like
I'm pretty sure you only edit the radius when you're not rotating around the x or y axis. Like if you're rotating around like y equals 1 or x equals 4 or something, that's when the radius is now like x minus something or x plus something.
that's what I'm imagining is kind of like, okay, we did this question up here, where this lower radius, right? It wasn't just 0 or anything like that. It was, you have to remember here we did, so the upper radius was, this is 4 minus x, but that actual radius is 2 plus 4 minus x. 2 plus 4 minus x. That's why I wrote that here. And this lower radius is just 2. So maybe that's kind of what they're getting at, right? So it's, this upper radius is 2 plus 4 minus x.
Yeah, that's exactly, yeah.
So in this case like this, I mean, it's just good to draw it out. I think the best way to do it when you're doing these problems is to not ask like with the formula, but just like ask how far away is that radius from the axis of rotation. So in this case, it would be 2 plus 4 minus x for this upper one.
Yeah, like you would subtract it, I guess, if it's like on the top. If the axis of rotation is on the top. Or whoever that was asked.
So if the rotation was at like 5, y equals 5, then the upper limit, well, the upper rotation would still be,
would be 5.
Would be 5, and the lower one would be 5 minus x. Yeah, 5 minus this x minus
4 minus x.
I guess it depends. Yeah, like she said, it depends on where the axis of rotation is. So like you'd have to account for that when you're. Yeah.
So just the best way to ask is just like how far away is this, right? How far away is that? So this is 5 minus 4 minus x. Yeah. Okay, well, so then that's the ideas. I mean, we didn't do too many super difficult questions from the chapter 6, but I think it's because like on the practice test there's going to be some hard ones, so I think we'll do that. Unless anyone has any other questions from chapter 6, I'll do whichever ones. And probably have trouble with whichever ones, but we'll see.
Can we do like the irrational kind of one? Like when they have 1 over something?
Sure. Maybe can you try to see if you can find an example? I'll see.
There's one in the textbook I found.
Which question?
Do you want me to tell you the number or the question?
The number. You can just tell me the number and I'll find
144.
144?
Yeah, I don't think it's that hard, but...
So for the following regions, find the volume generated when the region between the curves is rotated around the given axis. Okay. You said 144, right? Sorry, just making sure. 144.
Yeah.
Okay. So y equals 1 over 4 minus x. X equals 1. X equals 2. And it's rotated around x equals 4. Okay. So, what will this look like? Well, okay, so let's draw our graph like that, right? So that's our xy plane. We have 1 over x would look like that. 1 over negative x would look like that, right? And 1 over negative x plus 4 would look like that, where this is negative 4. So then we're looking for the region, for the volume of the region bounded by, so x equals 1 is going to be here, right? So that's maybe I'll do a different color just so you can tell it's a boundary. So x equals 1. Then
sorry to interrupt. Shouldn't it be on the right side? It's plus 4, right? Negative x plus 4?
Yeah, so then it moves this way, doesn't it? So then it moves to the negative direction. I mean, I'm thinking it would. Oh, I guess I have to fact. No, yeah, I guess it's negative x plus 4, and then I have to.
Yeah, that's the same as 4 minus x. That's the same as 4 minus x, right?
Yeah, that's the same thing as 4 minus x. Yeah.
You have to shift it 4 to the right.
Well, but
Right?
also, oh yeah, no, it's positive 4 that the thing is at. But why? Hold on. Because I factor out this, and it's going to be that? I guess so. That's probably the reason. Minus 4. Yeah, that's it. So we have to actually, you have to factor out the negative. So then it'll be the other way. So the thing will be at 4, and it'll look like this. Okay. So we're bounded by, we're looking for the area, or the boundaries of our region is x equals 1, x equals 2, which is right here. Like that. Okay. And we are revolving it around x equals 4. So I'll say like that. Okay. So let's choose, I kind of drew it too small, but let's choose an arbitrary, just like some cylinder here. What's the height? What's the radius of that cylinder? From here. So what's the distance from here to here? Right. Well, that distance will be if this whole distance, it'll just be x still. It'll just be x. Wait, no. It'll be 4 minus x. Yes, it'll be 4 minus x. So that red distance is going to be 4 minus x. Hopefully that makes sense. So we need our formula. So v equals 2 pi from 1 to 2 of the radius, so 4 minus x, times the height. And the height will just be 1 over 4 minus x. Okay. There. Yeah. And then dx. Notice here, v equals 2 pi from 1 to 2 of 1 dx. So v equals 2 pi times x from 1 to 2. So 2 pi, 2 minus 1, 2 pi. And that's the volume. Is that the answer?
It's an even number.
It's an even number. Oh, it's like a whole number? That's an even number?
No, you don't know the answer. It's an even number question.
Oh, okay. Sorry, I thought you meant the answer was okay, yeah. Well, let me like, how would I even figure that out? I don't know how I'd figure that out. Let's see.
What's the question number? I could probably.
144. 144.
This is chapter 6, right?
6.3, yeah.
Um, 2 pi?
2 pi is what I got.
That's right.
That's right? Okay, good. There you go. So yeah. So there's that one. So yeah, the important thing here that, you got to determine what that red arrow is. The length of that red arrow. That's pretty much the hardest part. Is determining that.
That red arrow, I'm sorry. It's from the axis of rotation to the differential?
Yeah, it is.
Okay,
yes.
cool.
That's right. Axis of rotation to the arbitrary
Wait,
cylinder.
Can we go through the radius again? How do we find the radius?
Of the cylinder?
Yeah, we used the shell method, right?
Yeah, this is the shell method. So you see, we have the axis of rotation here, right? I'll draw it a little bit bigger. We have our function going up like this, or you know what? I'll just draw it down here. So we have our axis of rotation. We have our function that goes up like this, and we're choosing a range that's like from here to here, right?
Mm-hmm.
So that's what we're doing. So we're choosing some random thing in here, right? Oh, and this is also the that's the x-axis. Okay, that's the y-axis. Sorry. So our, first of all, our height is going to just be the value of the function. And then our radius is, well, if from here to, we know from here to here is 4. And we know from here to here is x, then from here to here will be the bigger one minus that one. So 4 minus x will be here.
Okay, makes
So
more
let's do
sense.
this. Yeah, good. Yeah. Okay, so there's that. I guess it's time for, I mean, unless anyone has questions, but it's time for the break, and then we'll do the practice test after the 2019 previous year's midterm test or final exam. Okay. So yeah. Okay, so then I'll put up the break thing. I guess we'll do. There you go. And I'll say back in 15 minutes. So what time will that be? So we're back at 47. 47. Okay, so I'll be back then. See you guys in a bit. Okay, hi everybody. I'm back. So yeah, let's do the test. I have it here. Let's do the test. Let's see how long it is. It is 9 questions. So of course ours is gonna be shorter. First, I was thinking I'll do an example of the question that guy asked me before. I don't know who it was, but to do the FTC, but with both of the bounds are a function, right? So hopefully is that guy still here who asked me that?
Yeah, I'm here.
Okay, sounds good. So let's do this. Do you have a particular example, or should I just come up with one?
Can you use the same one that they did on the thing?
Yes, I forgot to change the camera back.
Hall
The study hall this morning. Oh, okay. I have to find it then.
Okay, 1 second.
Can you get it?
Yeah, I can get it.
Okay. So first I'll just write what it says. So F equals X, F T. Okay, so yeah, we'll do that and then start the practice test.
Yeah, I got it.
Got it? Okay.
I sent it.
Oh, okay. Yeah. Sounds good. Okay, so the question is let f of x equal. Oh, okay. This has a function only in one of the bounds, but it's okay. It's the same thing. Yeah. So 0 to x squared of 1 minus t e to the t squared dt. Okay. So we want to figure out where is f increasing, right? Where this function is increasing. So we need to figure out where its derivative equals 0. In other words, we're trying to find the derivative of this thing in here. So in general, I can say that f of, or should call this a big F. So big F, big F of x equals this integral, the area under the curve of this function. Small f of t equals 1 minus t e to the t squared. Right? So what this is saying is that we're doing, let me get this right here. The derivative of this, f prime of x, big F prime of x, is going to be equal to, this is the integral, so d by dx, of the integral from x squared to 0 of f of t dt, right? We're looking, so this is going to be d by dx of, now this definite integral is going to be the antiderivative of this, so big F of t, evaluated from 0 to x squared, right? So in other words, it's going to be d by dx is d by dx of big F of x squared minus big F of 0, right? We know the derivative of this is going to be just f of x squared minus f of 0, and I can plug that in here. So f of 0 would be 1 times 1, so f of 0 would be 1. F of x squared is just going to be square root 1 minus x squared e to the x to the 4, right? So it is here, yeah. Minus 1. Is f of 0, yeah, is 1. So this is equal to the derivative, f prime of x. Big F prime, the derivative of this starting function. Where are we? The derivative of the starting function is all the way down here, right? So we're going to look for where that's equal to 0, right? Where this, pretty much where 1 equals root 1 minus x squared e to the x to the 4. And, oh, hold on. 0. Felt like that should have been 0. But it wouldn't be 0. What else was there in the here, maybe let me try to so that's the derivative, but it has a 1 at the end, so that doesn't quite make sense. Evaluated from 0 to x squared. We took this, that's equal to that. That's just f of t. Derivative of that is capital F of t evaluated from there to there. Yeah, this looks right. None of that looks wrong. I guess how would I solve this? 1 minus it's not equal to 0. So
oh wait, wouldn't you use like FTC part 1 to solve this? So like you do the derivative of like x squared times like the inner function, and then like you sub in x squared, and then you do like minus 0, like the derivative of 0, which is just 0, and then you times it by the inner function, like in the integral.
Like here? Oh, actually, there is
like,
something that I
like,
forgot. Yeah. Mm-hmm.
Yeah, you need to multiply it by like the derivative of the bounds.
Yeah, there is something I forgot here. Yeah, there is something I forgot for sure. So, yeah, okay, I see there we go. So, the derivative of this is not that. The derivative of this is small f of x squared times 2x minus small f of 0 times 0. There we go. Yeah. So now we just do this. Okay, there we go. So we just say this is going to be 1 minus x squared e to the x to the 4 minus 0. And we're looking for where this equals 0. So this never equals 0. And where does this equal 0? 1 minus x squared equals 0. 1 equals x squared. X equals plus minus 1. There we go. That was the problem. So yes, when you take the derivative, it's a chain rule problem, right? So you take the derivative of the outside. The trick of the question is that the derivative of big F is little f. That's that. We also have to take the derivative of the inside function. And notice it would be the same thing, exact same process if this was another function here, right? You would just have the function in here, and the derivative would be not 0. It would be something, right? But yeah. Okay, so the question was asking for intervals of increasing, decreasing. So we know that it's going to change at -1. Well, it might change at -1 and 1. It'll also change anywhere that this doesn't exist, but it exists everywhere, so we're not a problem. So
Wait, 2x? Sorry, for the previous question, isn't there 2x?
oh yeah, yes, there's 2x. There's 2x here. Yes. So also x equals 0. That's another solution. Yeah. Okay. So now we're gonna just check. So we'll see. Let's try -2, -0.5, 0.5, and 2 for the derivative. So that's going to be, let me just type it all in here. E to the power of something to the 4. I'm just typing in like a template and then fill it in one by one. 1 minus squared. Okay. So the first thing we're testing is -2. Okay, so I got a positive number. Which means that f is increasing. Then I'll choose -0.5. f, I got a negative number, so f is decreasing. And I'll choose positive 0.5. Okay. And I got a positive number. And then if I choose 2, I will probably get a negative number. Yes, I got a negative number. Okay. So what that means is that we're increasing from negative infinity to negative 1 and 0 to 1. And there's our intervals. Yeah, so the hardest part is really finding that derivative. So you use the FTC. You kind of use both, not just kind of, you use both parts. Right, because this is equal to the antiderivative evaluated from these two, this to this. So that's part, I don't know which one's part 1, part 2, but that's the other part. And then the part 1 is, or again, I don't know which one, but the other part is this thing, where you take the derivative of big F, it's little f. So you don't have to evaluate any integral here, actually, right? You just say, well, the antiderivative, and then, yeah. Okay, so I think let's start the practice exam. And let's hopefully we get it done. So question number 1, unless anyone has any other questions, but we'll just start. So practice test 2019. So the first question is very similar to the last one. Big G of x equals the integral from -1 to sine x of t squared dt. And then we're solving for what g prime of 2 pi over 3 is. So we need to find g prime, right? So first of all, I'll say f of t equals t squared. So g prime of x is equal to the derivative of this integral, which is of f of t dt. So just put the d by dx, replace that with f of t dt. This, we know, not with excluding the derivative, we know that g prime of x, well, I won't write that, I'll just say equals d by dx of the antiderivative, capital F of x, capital F of t, right, evaluated from -1 to sine x, right? So this is equal to d by dx of, big F of sine x minus big F of -1, right? So then this is equal, so we'll take the derivative. So it's going to be f of sine x times cos x minus f of -1 times 0. So that cancels out. Now we need f of sine x. So f of sine x is sine squared x. So sine squared x cos x. And then we want to evaluate at 2 pi over 3. So sine squared of 2 pi over 3 times cos of 2 pi over 3 is a half, or pi over 2, which is not the answer. Okay, so -1 t squared. So the answer is, oh, how did I get pi over 2? G prime of, okay, so the answer is -3 over 8, no pi in there. So let's see what went wrong. Big G took the derivative.
I'm pretty sure -3 over 8 is the answer.
Yeah, -3, that's the answer. That is the answer.
Yeah.
Of this expression?
You got it right. You just have to find the exact values.
Exact value of this expression here, like of this, what's happening here?
Yeah.
Oh, I didn't do cos of.
Yeah.
I didn't do cos of the second one. I just multiplied by the second one. And now I got -3 upright. Okay, there we go. Just my ability to type things into a calculator is what's causing us trouble. Okay, so there you go. That's the answer. That was right. Okay, so anybody stop me? Otherwise, I'll just keep going. So I think I'll skip the next one because it's a hyperbolic function and we don't need hyperbolic functions. I can do it, I guess. I guess maybe we'll try it, but limit as I won't spend too much time on it if it gives us trouble. So limit as x goes to -infinity of x sine.
Actually, could we skip the hyperbolic? I kind of don't want to see anything that I won't be seeing on the test tomorrow. Is there
Yeah,
anybody else
and
fine with that?
hyperbolics are not on the test at all.
Yeah.
Okay,
Yeah,
then
we can just skip it.
Okay, then we'll just skip it. Okay, sounds good. So 3 is let f of x equal that, then f prime. No, this is also not on the test. F inverse prime. That's from last test. So I will move to the next one. So number 4 is evaluate the integral from 0 to cube root pi of, this is directly from the textbook, I think, cos squared t cubed sine t cubed dt. Okay, so this will be a u substitution question. So we can say u equals t cubed, du equals 3t squared du, or dt, sorry, dt, right? So we have our dt and t squared, right? dt t squared. So it's going to be 1/3 the integral from 0 to, not that. So we're going to have to apply the u. So apply that to our upper limit, right? So it's going to be cube root of pi cubed, so it's going to be pi. And then t squared is going to go away. It's just going to be cos squared u sine u du. Okay, 1/3 0 to pi of, now I'll say another u substitution. So I can say, or I'll say v equals, I guess I'll try cos. Yep, I guess I'll say cos. Don't think it actually matters. Well, maybe it'll matter. Cos u. So du equals negative sine u dv equals negative sine u du. So this will be -1/3, right? U squared dv. Sorry, v squared dv. Yeah. Okay, so now we just evaluate the integral. It's going to be v. Oh, I have to change the bounds too. Sorry. So v equals cos u. So cos of pi is -1. Makes sense. And cos of 0 is still the bond. Cos of 0 is 1. So we're going from 1 to -1. So v cubed over 3 from 1 to -1. -1/3. So this is going to be -1/3 minus 1/3. Okay. So this is going to be -1/3 minus 2/3. So -1. Is that the answer? The answer. Oh, I just did my evaluation wrong? Everything's right until this last line. Sorry, I made a mistake. -1 to 1, 1/3. So, okay, well, they took out the third, right? They took out the third here. So it's a 9th, right? So then it's just v cubed. So v cubed is -1 minus 1. So 2/9. I get how that's 2. Maybe I just did my math wrong. That's probably what it is. I just did my math wrong at the end here. So -2/9 is the answer. And yeah, you're allowed to just move that out. Move the third out. Or move this in if you wanted to, but yeah. Okay, so let's try the next one. So that was actually just part A. So part B is going to be another integral. So it's going to be.
Oh, hold on. Can I ask a question?
Yeah.
For your integral, how did you change it from third root of pi to just pi?
Because we said u was t cubed. So whenever you do the u substitution with a definite integral, you apply that, right? So I just cubed that, and then it's just pi.
All right, thanks.
No problem. Okay. So the next one we're doing is 1 over the square root of 3 plus 6x minus 9x squared dx. So this one is most likely going to be one of the inverse trig derivatives, or inverse trig integrals. I just have to find them, so hold on one second. Because I don't know, I can't do it without it. This would be in right before related rates. Sorry, I just got to find it.
It's one of completing the square problem.
Yes, looks like it.
Yeah.
Looks like it. Oh, no, before related rates. Okay. Just need the formulas for the inverse trig ones. Okay, so it looks like it's going to be a sine inverse one, because the sine inverse one is 1 over root something, the integral of 1 over root something. So that's what we have. What we need in the bottom is a squared minus x squared. Yeah, a squared minus x squared. So one way to do that is take this quadratic and to complete the square. Right? So if I just take this to the side, negative 9x squared plus 6x plus 3 is equal to, sorry, we're waiting for food to come, so it's gonna, oh, okay. I'm gonna keep having to look here. Okay, I think it's good. So to complete the square, you have to, ideally we're getting into something like this, x minus a squared plus c, right? That's like that's our goal, to have a perfect square factor and then just some constant at the end. So to do that, you need to factor out the leading coefficient. So it's going to be 9, well, you have to factor out a negative 9. So it's going to be x squared plus this over negative 9 is going to be negative 2/3. Got to answer the phone. So negative 2/3 x plus minus 1/3 at the end. Okay. So yeah, you have to factor out the first leading coefficient to complete the square. So this is going to be negative 9 times, now what we want is we want to have, let me think here for a second. Okay. What we want is to have a number at the end here, right? That makes this a perfect square with that number at the end to make it a perfect square trinomial, right? So to do that, to decide what number it is, we take that middle number, we divide it by 2, which is negative 1/3, and then we square it. So it's going to be 1 over 9. So that's what it's going to be. So plus negative 2 over 3x plus 1/9 minus 1/3, and then we have to now this is part I'm a little shaky on, but we'll see. So definitely we have to subtract 1/9 because we added 1/9 there, but we actually added negative 9/9, right? We actually added negative 9/9. So we have to do negative 1/9. So adding that times negative 9, right? So that's just going to be 1 plus 1. Now, if we make a mistake, then that's where the mistake came from, but I'm pretty sure that's where it is, right? Because we're this multiplied in the front. So now this will factor nicely. I guess I'll just plug it in, but because I don't particularly want to try to work it out, but so 1 negative 2/3 and then what do I do with this? Oh yeah, this is no, this is where Yeah, okay, so never mind. Okay, so I didn't really make a mistake because that is correct to put a 1 here, but that doesn't really help us. We're putting the brackets here, so technically it's okay. We can just subtract a 9th here. Yeah, that's all right. So we don't have to worry about anything about that. So we just subtracted a 9th there. And then, so -1, -2/3, and a 9th. So the solutions are 1/3 and 1/3. So it's going to be -9 times, this factors into x minus a third squared minus a third minus a 9th. So let's multiply that all in. Multiply that all in. So we have those together, negative a third minus a 9th. So it's a 9th. I'll just type that here. Negative a third minus a 9th is -4/9, right? So -9 x minus a third squared minus 4/9, and it's looking good because look what's going to happen. Oh, is it looking good? Yeah, it's looking good. What we're going to end up with is going to be -9 times x minus a third squared plus 4. Right? That's so we've converted this quadratic into that. So I can rewrite this as, in fact, I can rewrite this as 2 squared minus 3 squared x minus a third squared, which I can rewrite as 2 squared minus 3 x minus a third squared, like that. And if I put that back into my integral, right, so 1 over the square root of 2 squared minus 3x minus a third squared. That's exactly what the definition of the sine, like the not the definition, but there's a specific formula, right, for this this integral right here, and it's equal to sine inverse of this thing, not squared, so 3x minus a third over this, so 2 plus c. Oh, and did I do a plus c on the top, or was it a definite integral? It was definite. This is indefinite, right? Yeah. And I lost a third somehow. Okay, for some reason. Oh, what did they do? My answer is identical, except they have a third here on the front. I don't know why. Let's try to figure that out.
We factor out a third in the starting. Wait, that was the previous question.
Yeah. I had no idea why there's a third there. Because their answer is just 3x minus 1. Just multiply that 3 in. Okay, let's see where the third comes from.
Why would it be over 2?
Because the formula is, here, I'll write it out. So it's the formula of dx over root a squared minus x squared equals sine inverse of x over a plus c.
Okay. Gotcha.
Oh, so they did it with a... Did they have to? I mean, it gets a different answer, but... I guess we can't go right from this to this to this. So the only difference that they did is, first of all, okay, let's take that integral here. So that's 1 over square root of 2 squared minus, multiply the 3 in, so it's 3x minus 1 squared. And, okay, I guess this can't be an expression. This has to be just a variable. So we say u equals 3x minus 1. So du equals 3 dx. So that's where the third comes from. 1/3, 1 over integral of 2 squared minus u squared du, right? And then now this is equal to this is equal to sine inverse of u over 2 plus c. So this is equal to sine inverse of 3x, 1/3, 3x minus 1 over 2 plus c. Sorry, it's looking messy. Yeah. There. So I guess I didn't know that. I mean, I did it differently. So this, yeah, it makes sense. This can't be an expression. It has to be like a variable in there. I mean, yeah, it has to be a variable in there. So, okay, then if anyone has any questions for that, then let me know. Otherwise, I'll move on. Is that question done?
Scroll up a little bit, please, for a second. I'm just confused from how it went to the completing the square part to the after the completing the square part.
So we completed this. Hold on, sorry.
I think I see it. Thanks.
You okay? You got it? Right. That's.
I think I see it. Yeah.
Okay, then good. There you go. So, then let's go to question 5 then. Question 5 is this. Consider a pool shaped like the bottom half of a sphere. The radius of the pool is 10 feet. Hint, when the water has a depth of h and the radius has radius of the sphere is r, there's a special volume formula. So, okay, let's just first draw a picture. We have a pool shaped like a bottom half of a sphere. This radius is 10. Okay. When the water has a depth of h, so water has a depth of h, okay. Oh no, that's not part of the thing. Radius sphere is r. Yeah, okay, it's fine. So part A is asking, what when the pool is being filled at a rate of that, so dv dt is 25, so it's being filled, so it's positive. Find the rate at which the depth of the water is changing. We're looking for dh dt when h is equal to 5. So to do this, we're going to have to find a relation, right? So first of all, the volume of this stuff down here, it's given to us. So the volume of that cap is pi over 3h squared, 3r minus h. Okay? And so we're looking for dh dt. We're looking for dh dt. So we only have one variable here. The r, that's the radius of the sphere. We know that's 10. So we just take the derivative. V prime equals with respect to time. All right, so it's pi over 3 h prime times, so actually this is product rule. Actually, I should multiply this in first. So multiplying that in, so it's not prime. Pi over 3 times 3 h squared r minus pi over 3 h cubed. These 3's cancel. That's an r. And that's a pi. Okay, so now taking the derivative, v prime equals 2 pi h prime r prime minus pi over 3 3 pi over 3 h squared h prime. Okay, and we know everything except h prime, so we can just factor it out. 2 pi r is a constant, so r goes to the front. Thank you. Yeah. So I'll just factor out the h prime now, so minus pi h squared h prime, so v prime over 2 pi r h minus pi h squared equals h prime.
Sorry to interrupt, but was this volume given in the question?
The formula for the volume?
Yeah, the
yes.
volume you're using.
Yes, yeah,
oh, okay.
that was given in the question. So this is 25 over 2 pi times 10 times 4 minus pi times 4 squared. Right, the height was 5, not 4. So this is 5. This is 5. So, well, I can take a 5 out of everything. Right, so that's 5. I can take a 5 out of everything again. So it's 5. 1. So 10 pi minus pi over 1 equals h prime. H prime. So 1 over 9 pi equals h prime. Which is very close to what they have, but they have 1 over 3 pi. So I lost a 3 somewhere. If the water's changing, yeah, did I just mess up algebra? Did I just mess up my algebra a little bit here? So this was just to write this a little nicer. 1 over 10 pi minus pi. Okay, let's just check back my algebra. So the volume is pi over 3 h squared 3r minus h. Multiply that in, so it's going to be pi h squared r, good, minus h cubed pi over 3. So taking the derivative of that, it's 2 r is a constant, pi h prime minus, where'd the 3 go? Where'd the over 3 go? There you go. That was the problem. Okay.
No, when you take the derivative, the 3 comes down, no? Multiply by 3.
Oh, yes, never mind. Okay, I thought I had it. Yeah, take the derivative, that comes down, cancels, so it's h squared h prime. And now r 2 pi h minus pi h squared h prime, v over 2 pi r h minus pi h squared. And I'll just write this out fully. So v is 25.
You know, when you're deriving the volume, there should be a pi over 3 in the first term. Not the second term, but the first term, I think.
Here?
No,
here?
like when you derived it after,
Here?
yeah.
Well, the
Because pi
derivative.
over 3 is constant, right?
So I multiplied. The thing is, I multiplied the pi over 3, and then these 3's would cancel. So there's no more pi over 3 on this term. This term lost the pi over 3. So you see here, like if I did pi over 3 h squared just times 3r, right, just distributing to the first thing, these 3's cancel. So it's pi h squared r.
Okay, but it should be in the second term then. Yeah, I see.
Right, so it's there. Yeah, it's there. But then here we take the derivative. Okay, did I just punch this in wrong? So r was 10, right? R is 10, yeah. H is 5 minus pi 5 squared equals h, well, it already equals h prime. I'll just type this in without doing any weird things with 5s and see if that, maybe I made a mistake there. So 2, oh yeah, no, 2 pi.
Yeah, it's right this time.
5. Oh.
So it's going to be 25 over 75 pi, which is 1 over 3 pi. Yeah.
So what did I do wrong before? What did I, okay, take a 5, yeah, so take a 5 out of here. Take that 5, take that 5.
So you factor out a 5 from the 10, but then left it as a...
So this should be a 2.
Yeah, you left it as 5.
Oh, so it's 4 pi minus pi.
Yeah.
There we go.
Got it. There you go.
So 1 over 3 pi. Okay, that was the problem. Okay. So, yeah, that's the answer to that one. So part B is going to be this. After this question. Okay. Later, when the pool is being drained, if the depth of the water is decreasing at a rate of 1 inch per minute, so dH dt equals negative 1 inch per minute. Well, now we're going to negative 1 inch, so negative 1 over 12 feet, The depth is 2. Find the rate at which the volume is being drained, right? So find d by dt. So this is later on, different than first situation. We're looking for dv dt. It's being drained. The height is going down by 12 when the height is by 1/12 when the height is 2. And yeah. So again, I have to use my volume equation again. So v equals pi over 3 h squared 3r minus h. Okay. And then I know I'm looking for v prime, right? So I just take the derivative. Again, I'll multiply it in actually. So it's going to be pi h squared r minus pi over 3h cubed. So now I'll take the derivative is pi r h prime minus pi h squared h prime. And I know everything except v prime. So pi times 10 times the height is 2 negative a 12th minus pi 2 squared minus a 12th. V prime. So this is going to be negative 20 pi over 12, so negative 10 pi over 6, so negative 5 pi over 3. And then this is going to be negative 4 pi over 12, so 4 pi over 12, actually positive 4 pi over 12, so pi over 3. Right, so this is going to be 4 pi over 3. Or negative 4 pi over 3. Sorry, negative 4 pi over 3. And somehow I lost the 2. 20.
You have to add the 5 pi and the pi, no?
Yeah, and that'll make negative 4 pi. Make negative 4 pi over 3, which is this number is wrong. It should be a 10 up here. Let's see why. 6. Oh, 20. What?
I think that might be an issue with the solution.
You think so?
Because I don't.
When you took the derivative, I don't think you multiplied by 2.
Yes.
No, I got negative 10.
Yeah.
Oh, we were supposed to have an extra 2 at the top.
Yep.
Right?
There we go. So that will be a 3, and that'll be a 10, and that will be a negative 10 over 3. So it's negative 9 over 3, so negative 3 pi. There we go. So there's that. Let's see, are we done the question? Yeah. Okay, I'll be back in just like 1 second. Just got to get something from downstairs. Okay, so just a second, guys. Okay, so next question. Does anyone have any questions for this one? For this related race problem? So, number 6 is next. So find the area of the region bounded by the curves y equals 4x minus x squared, y equals x. and the positive x-axis. So this is just a 6.1 question, right? So this will approximate, if we have our x and y axis here, right? There's my y equals x. And my negative x thing, if I was just looking at it, I guess I would say it kind of looks like that. And looking at the picture that is what it looks like. Okay, good. How I could tell that is, okay, it's facing downwards. It doesn't have a constant term, right? It doesn't have a constant term, so it's going to pass through 0, 0. And it's a positive linear term, so it's going to move that way. So that was my guess. And yes, there you go. So we're looking for the area bounded by that, and the positive x-axis. So we're really looking for this section, right? So to do that, we have to notice that we got to split right here because there's an intersection point. Because a good way to check, and this is what Saeed was doing this morning, Professor Saeed. So you look at your slice your differential you're looking at. It should always touch the same function on each end. So starting here, it touches a different function on each end here. So you got to split it, right? So I'll just erase that. And so to find this integral, we got to first of all find that point that it intersects at, right? So 4x minus x squared equals x. 3x minus x squared equals 0. X 3 minus x equals 0. So x equals 0, they intersect. X equals 0, and also x equals 3, they intersect. So that's at 3. So we're going to integrate from 0 to 3 of just the top function minus the bottom function. But in this case, the top function is just x, y equals x. The bottom function is just 0. So we don't even have to integrate that. We're just looking for the area under the curve of that function. So dx. And we want to add on to that this area here, right? This blue area. And so that's going to be a little bit different. That's going to be the integral from 3 to this x value. That x value is going to be the other 0 of that. So we're going to look for where 4x minus x squared equals 0. The other 0 of our quadratic function. So 1 is at 0. So x, 4 minus x equals 0. So there's the one that's at 0. And our other 0 is at 4. So that's at 4. So we're integrating from 3 to 4, right? From 3 to 4. And we do, again, the top function minus the bottom function. But again, the bottom function here is just 0. So we just do the top function. We're just finding the integral of that function between 3 and 4. So that function is 4x minus x squared. Dx. And now we just have some integration to do. So the antiderivative of that is x squared over 2 evaluated from 3 to 0. Or I always say it backwards, but 0 to 3. And then this antiderivative is going to be 2x squared minus x cubed over 3 evaluated from 3 to 4. So this is going to be 9 halves plus, and this will be more complicated. So 2 times 16 is 32, minus 16 times 4 is 64, 64 over 3. Minus, evaluated at 3, so 18 minus 9. So 9 halves plus, don't know what that is, but I can subtract, so this will be 9, so it'll be minus 9 at the end here. And then now this thing, 32 minus 64 over 3 is 32 over 3. And so now I can just add all these together. So that plus 9 halves minus 9, I got 37 over 6, which is the answer. There you go. And there's that. Okay. So I'll do question 7. Yeah. Of course, anybody can ask questions whenever they want. I should have the chat open. Questions. Okay. Yes, if someone asked you if volume by slicing is on the exam, yes. No, they're not here. Never mind. Oh no, by slicing. Sorry, I don't. That's the one that I don't know. So actually, I guess not. These questions. Someone from the call. These questions are the 2019 midterm from last year. They're from D2L, from the test 3 section of D2L. No problem. So find the volume of the solid obtained by rotating this region, which I'll write down in a second, about the line x equals 3. Okay. So the region is obtained. The region is bounded by y equals x cubed plus 5 over 2. Y equals 9/2 minus x squared. X equals 2. And we're rotating about x equals 3. So let's try to draw this. This would be about like that, right? Where that's, this is our x and y axis. Okay. Negative x squared 9 over 2 would be kind of like, I don't really know, like that, I guess. Should be a different color actually though. Be like that. And x equals 2. Now I have to find where these, oh, yeah, let's find where these intersect and let's see if x equals 2 is past or behind that. So where does x cubed plus 5/2 equal 9/2 minus x squared? Okay, so I can say x cubed equals 2 minus x squared. So x times x squared minus x. Oh no, sorry. X cubed plus x squared equals 2. X squared x plus 1 equals 2. Oh, no, I don't want it equal to 2. Sorry. Making mistakes. So, solving for x. So I'll put it all on one side. X cubed plus x squared minus 2 equals 0. And I'll just plug this into my, plug this into my calculator. 3, so it's 1, 1, 0, negative 2. So my solutions are x equals 1, and that's it. That's the only real solution. X equals 1. So that means that the x value of this point is 1, and we're doing the region ends at x equals 2. So it's going to be past that. It's going to be right there. So that's x equals 2. And we're, well, I guess I'll write over here because x equals 2. And we're rotating around x equals 3. So that's our rotation axis. That's our y-axis. That's our y-axis. X-axis, y-axis, and all that. So the region is bounded by, let's just be precise, find the volume of the solid obtained by the region bounded by that, and x equals 2. Oh, so it's this little bit right here. That little bit right there. Okay, that's the little bit, that's the area we're finding. The rotated solid we're finding. Okay. So I think I'll do this as a cylindrical shell. Because, yeah. Can I do it as a cylindrical shell? Yeah, I think I can. So, of course, it's very small, so it's going to be hard to show. But let's choose an arbitrary thing here. Right? Let's choose an arbitrary thing right there. That line. What's the distance that line is from here? And also, what is the height of that line? So first of all, the distance, which is going to be the radius, is going to be 3 minus x. Okay, 3 minus x. So 3 is this whole thing. X is the point it's at. So this distance is 3 minus x. Okay. And that height, well, the height is going to be the top function minus the bottom function. Minus So it'll be, well, okay, minus 9/2 minus x squared. Okay, and that'll be the height. So we can integrate, right? Oh, maybe I'll move this to the side a little bit. Oh, it doesn't like me scrolling and using the pen at the same time. There. That over. Okay. So if I put this as a volume, it's going to be 2 pi times the integral from 1 to 2, of r times h, right? R is 3 minus x times the height. And the height is that. So let's see if we can simplify that at all. So it's going to be x cubed negative minus 4x, so minus 2. So plus x squared minus 2 dx.
Can you explain how you got that equation for height again?
For height, yeah. Well, it's just gonna take like this distance here. It's very small again. I know. I'm sorry, but it's just gonna be the top, the function evaluated at the top, which is this function, right? Minus evaluated at the bottom.
Oh, okay.
Which is that function, right? So it's just that minus that. Like that. Yeah. So then, yeah, simplified. I'm hoping I simplified that right. 5 minus 9 is negative 4. Negative 4 over 2 is negative 2. Yeah, that looks right to me. Negative 2. So let's just integrate this. So v equals 2 pi, still from 1 to 2. I'm going to multiply this in. So 3 times 3x cubed is 3x cubed. 3 times x squared is plus 3x squared. 3 times negative 2 is negative 6. Negative x times x cubed is negative x to the 4 minus x cubed plus x plus 2x dx. V equals 2 pi integral from 1 to 2 so x to the 4 comes to the front minus x to the 4 plus 2x to the 3 plus 3x squared plus 2x minus 6 dx. Okay. So we can just integrate this now. V equals 2 pi from 1 to 2. Sorry, I always write that first and then I realize I'm integrating. So negative x to the 5 over 5 plus x to the 4 over 2 plus x cubed plus x squared minus 6x dx. Oh, not dx. Just that. Evaluated from 1 to 2. V equals 2 pi. So now evaluated at 2. I guess I just have to write it out. So 2 pi times, first bracket, is going to be negative 2 to the power of 5 over 5 plus 2 to the power of 4 over 2 plus 2 to the power of 3 plus 2 to the power of 2 minus 6 times 2 minus negative a fifth. I can't read that. Negative a fifth plus a half plus 1 minus 6. Okay. So 2 pi times now, it's an odd exponent, so it's still going to be negative. And now 2 to the power of 5 is 32, so negative 32 over 5. Even exponent, well, it's not a negative thing, so there'll be 16 over 2, so 8. No, 2 to the 5 is 32, 16. Oh, 8, yeah, never mind, sorry. Divided by 2, I forgot we divided by 2. 8, 4, minus 12, plus a fifth, minus a half, minus 2, plus 6. All right, yeah, I guess I'll be like that. Okay, so 2 pi. 2 pi times, so 6, this makes a negative 6, negative 2, positive 6. Wait. 6 negatives. Here, I'll do one at a time. Okay. 4, -8, -4, 4, 12. So it's 12 plus a fifth, so minus 31 fifths minus a half. Hope we did that right. Okay. Okay, so I'll just say 2 pi times 12 minus 31 over 5 minus a half. So 53 pi over 5. That's the right answer. 53 pi over 5. There we go. Okay, so kind of a lot of writing in that question, but it's okay. We did it. Okay, I'll just move on but anybody can let me know if they have a question. So number 8 is consider the function f of x equals root x ln x. Find the intervals where f is increasing or decreasing. Okay, so it's increasing or decreasing changes when f prime of x equals 0. So the derivative is the first one times the derivative of the second one plus the derivative of the first one times the second one. So ln x. So just took the derivative. I'm going to look where this is equal to 0. So it's going to be 2x plus ln x times x over 2x root x. Just combine the fractions there. So this times this is 2x. Right? That times that is 2x. And this times this is x, or ln x times x. And then multiply the bottoms. So 2x root x. Okay. So now I just need to check where the top is equal to 0. So 2x plus ln x times x. Can divide everything by x, so x equals 0 is a solution. So 0 equals 2 plus ln x. And we're looking for ln x equals -2. So x equals e 1 over e squared. Ln is ln of 1 over, yeah. Okay, just got confused there for a second, but yeah, okay, so there you go. So there's our other solution, 1 over e squared. So these are the two places where well, not the only two places, but one of the two places where the critical point, these are critical points. One of the only two places where it can switch from increasing to decreasing or decreasing to increasing. The only other point would be where the derivative does not exist. So where the derivative does not exist. And that's also at 0 though. So it's okay. We don't have to take that into consideration. But that's another place where you have to check if it's a critical point. So the only time this equals 0 is if x equals 0. Yeah, so that's the only time. So yeah, there you go. So we have an interval now. Right, we have 0, 1 over e squared. So I don't know how big 1 over e squared is, so I don't know what's something in between it. 1 over e squared is, so 0. Yeah, so 0.1 would be a little lower than that. Yeah, don't worry, that was good, yeah. And 1. So let's test the first derivative and see what it's like at those points. So let me copy that. That's our first derivative. Okay. So maybe we can do the ones, and OneNote kind of freaks out on me a little bit if I move around too much. Oh, yeah, no, it's doing the thing again. Okay, I'll just restart OneNote. Okay, I think it should work now. Yep, there we go. So at 1, it would be 2 plus ln of 1 is 0, right? Ln of 1 is 0. e to the power of 0 is 1, yeah. So it would just be 2 over 2, so it'd be 1. So it'd be positive, so it would be, the function's increasing. Probably it'll be negative, so negative 2 over negative, well, it does not exist there. Well, you can't say, it wouldn't work. Well, I guess I can combine this into x to the 3 halves. And can you do negative 1 to the 3 halves?
You could factor out the x, because the other side is equal to 0, and just get rid of it. In the previous step, you had 2x multiplied by root x. Factor out an x from everything, and then it'll be x over x, and it'll just cancel out.
Factor out the x on the top. Yeah.
And the bottom. So
yeah.
You can factor the x from the bottom and the top, and then maybe it'll make it a little easier.
It would make it easier, but it wouldn't solve this one problem I'm having of I have to do. Yeah, I can't do it. I have to do negative 1 to the 3 halves. And even if I did that, then this would end up being just a root x. Cancel out both these x's. And I still can't do root x, like square root of negative 1. Right? So it's just not defined after that. I guess maybe it's just like, it might just be not defined. Right?
Yeah, because if you look at our bottom, that's going to be our horizontal asymptote, and should be a vertical asymptote, and shouldn't exist past our 0 on the left side.
Yeah, so that seems right to me. And also just like the derivative doesn't exist past negative, right? So it just doesn't go. Okay, well, let's see what happens. So then let's try 0.1. So it's a lot easier now. I can just do 2 plus ln of 0.1 over 2 times root 0.1. And I didn't do root 0.1. There you go. So I get a negative number, so it's decreasing. So it looks like our only, it looks like it's decreasing from 0 to 1 over e squared. It's decreasing. And it's increasing from 1 over e squared to infinity. And yes, that's correct. Okay. So classify the local extreme values for f of x. So local minimum at 1 over e squared. Oops. At 1 over e squared. There you go. Oh, wait. Negative 2 over e squared? Sorry, and then I have to actually find the actual value of it. Sorry, I didn't do that. So the actual value is, you have to just like calculate what f of 1 over e squared is. So f is root x ln x. So it would be root e to the negative 2 ln e 1 over e squared. So this is, this would just be, well, let's just write it out. It'd be e to the negative 2 over 2. So e to the negative 1. And this would be negative 2. So this is equal to negative 2 over e. So 1 over e squared, negative 2 over e. Those are e's on the bottom. That's a local minimum. Okay, we're on the last page. Find the intervals where the graph of f of x is concave up or concave down. So we take our derivative. I think I could just take this derivative. So 2 plus ln x. 2 plus ln x over 2 root x. So that's our f prime of x. And so I want to take the derivative of this. So I will have to do my favorite, well, not quotient rule, but almost quotient rule. 2 root x to the negative 1. So the derivative of that is the derivative of the first one. So it's just going to be 1 over x times the second one. So it's going to be 1 over x 2 root x plus the first one, 2 plus ln x, times the derivative of the second one. It's going to be negative 1 times the second one, 2 root x to the negative 2, times the derivative of the inside there. The derivative of the inside is going to be 2, 1 over root x. Okay. So 1 over 2x root x plus, well, actually minus, it's going to be 2 plus ln x over 2 root x squared root x. Okay, so I will start simplifying. So 2x root x minus 2 plus ln x over 4x root x. Okay, so I just need to multiply top and bottom here by 2. And now we have the same denominator. So I'm just going to say this is 2 minus 2 plus just 2 minus 2 plus ln x over 4x root x. So that's nothing. So it's just negative ln x over 4x root x. Okay, that's our second derivative. Make that better. I want to know where negative ln x equals 0. I want to know where ln x equals 0. So where x equals e to the 0, x equals 1. Okay, so that's the only place where we can have an inflection point. Okay, so where it goes from concave up to concave down, right? And or concave down to concave up. So let's test this. Let's do a second derivative test at negative. Oh well, I guess easier to just do 0 and 2. So the second derivative at 0, well, ln of 0 doesn't exist, so we can't do that. So 0.5. Ln of 0.5 is, well, I'll just type the whole thing in actually, sorry. So I'll just type the whole thing. So a negative ln of 4 times, sorry, what I'm saying isn't what I'm typing. So okay, so negative ln of 0.5 over 4 times 0.5 times the square root of 0.5. So I got a positive number, so that means it's concave up. It's positive, so it's concave up. And then I'll try 2. I got a negative number, so it's concave down. So that means we're concave up from, oh, one thing we forgot to check. Where does this not exist? Where does the denominator not exist? Well, the denominator doesn't exist where x equals 0. So we also have to check there. Also have to check there. Right? So I'll try negative 1. So negative ln of negative 1 over 4 times negative 1 times root negative 1, I can't do that. Okay, so it doesn't exist past here. Right? The function doesn't exist there. So we're concave up from 0 to 1. Okay, so concave up from 0 to 1. And we're concave down from 1 to infinity. Yep, that's right. And so then our inflection point is at 1 f of 1, right? 1 f of 1. That's the next part, is just to find the inflection point. So it's at 1 f of 1. And so our function f of x was somewhere. Here, f of x, root x ln x. So we're looking for root 1 ln 1. So 0. Yes. Which is 1 times 0, which is 0. So 1, 0 is our inflection point. Okay. And so we're on the last question now. So looks like an optimization question. A rancher will use 600 meters of fencing to build a corral in the shape of a semicircle on top of a rectangle. Find the dimensions that maximize the area of the corral. Okay. So in general, we have a thing that looks like this. It's a circular top, right? And like that. So we're trying to maximize the area. So we need an expression for the area of this thing right here, right? So if I call this y, call this x, we can find the area. So the area of that bottom bit is x times y. The area of the top is going to be, so the area of a circle is pi r squared, but we're dividing it by 2 because we're only taking half. And r is x over 2 squared. Right, so plus pi, and I'll just write it as x squared over 4 over 2. So x squared over 8. And so another thing we know from this value right here is that the perimeter has to add up to 600. So 2y plus 2x plus half the circumference of the circle. So 1/2 2 pi r. But remember the radius is going to be x over 2. So it's 1/2 x over 2. This is equal to 600. Using this equation, we can get an expression for y in terms of x, put it in, and then take the derivative and all that. So these cancel. 2y plus 2x plus pi x over 2. Okay. And so I can just multiply everything by 2, I guess. So 4y plus 4x plus pi x equals 1200. So this is going to be y equals 1200 minus 4x minus pi x over 4. Okay. So I can take that and plug that into this formula. Okay, so that's our expression for y. So a equals x times 1200 minus 4x minus pi x over 4 plus pi x squared over 8. Okay, I'll simplify this a little bit. So 1200x minus 4x squared minus pi x squared all over 4. Plus pi x squared over
plus pi x squared?
No, because we moved it over, so it'd be minus. So it should be negative. That looks right to me. So a equals I'll multiply up here by 2, so it's 2400x minus 8x squared minus 2 pi x squared plus pi x squared all over 8. So this will cancel into just negative pi x squared. And now we can, I guess I can combine this too. So a equals, so it'll be negative 8 minus pi x squared, okay, plus 2400x over 8. So 8 prime equals 1/8 times negative 8 minus pi times 2 times x plus 2400. we want to know where the derivative equals 0. So 1/8 times negative 16 minus 2 pi x plus 2,400. I guess I may as well multiply that x back in. That didn't really help us that much. So 0 equals, so it's going to be negative 2x minus pi over 4x, or yeah, pi over 4x, I guess. 2,400 divided by 8 is 300. And so now I just move this over. So negative 300 equals negative 2 minus pi over 4x. I know I'm factoring in and out that x all the time. Negative 300 over negative 2 plus pi over 4. These will cancel. So that equals x. So 300 over 2 plus pi over 4. Yep. So I get x is approximately equal to 107.703. So 2 plus let me just see. Their answer is, let me just see. If I multiply this by 2, no, if I multiply this by 4. Okay, let's see if I made a mistake. So it's very close to the answer. Their answer is 600. We're not actually at the answer yet, but just looking forward a little bit, is pi plus 4. So which is close. If I multiplied this by top and bottom by 4, we would have twice as big. It would be 2 times as big. So I lost the 2 somewhere. Negative 2x. Okay, let's look. Let's look here. So, and then maybe we may as well start right back at the start. So, xy. This would be 1/2 pi r squared. R is x squared over 4. So this is just over 8. Okay. Then we know 2y. Oh, 2y plus x, not 2x. Right at the start. We're not taking 2 x's. Right? So it's 2y because it's this plus this. X is just, we're just using one of them. Right? Not just that. So there we go. So this would be a 2. This would be a 2. I mean, that would be nothing, and that would be a 2. So this would be a 2. So this would be a 2. This would be a 2. This would be a 4. So this would be a how did that turn into an 8? How did what? How did that turn into an 8? Don't know. It should just be a 4. Oh, it was an 8. It was an 8 here. That's why. Okay, never mind. Yep. Never mind. I'm confusing myself now. So then this is a 4. This is going to be multiplying by 2, so this is an 8. So this is just a negative x. So this is just a negative 1. So this is just a 1. So this is going to be Still not quite right, because look what happens if I multiply by 4. It's going to be 1200 over 4 plus pi, which is still off. The top is still 2 times too big. So
Did we have to multiply the 1 over 8 into the bracket?
here, this one?
Yeah.
So I multiplied it in here and then here. So it'd become a negative 1x minus,
Can't the minus, cancel out?
With what?
Like, since you're rearranging, like, multiply both sides by 8. I don't know if that's right.
Yeah, you could do that. You could do that.
I'm not sure. I'm not good at math.
No, but that makes sense. 2 over 4. I guess that would be the same thing as if, like, right now I could multiply everything by 4. Right? And that would do the same thing. Right? Right here. What'd you say? Sorry?
Would that even change the answer?
It shouldn't. Shouldn't change the answer, no.
Oh.
Shouldn't. But yeah, it might be easier to do like that. So, 2,400. Yeah.
A little more. I think the second term or the last term, the pi x squared should have a 2. Down, like the third line.
Here?
Shouldn't there be a 2 in front of the pi x squared?
So it was multiply everything by 2. So there would be a 2 pi x squared plus pi x squared over here. From here. So that goes away. You see what it did?
Yep.
So yeah, so that I'll leave it there just so it's see. But yeah, it's there. So that's just pi x squared. Well, why don't I? Oh, never mind. I can't. Okay, actually, I will. It's confusing me now to see that, so I'll just erase that. It's a pi. Factor of the x squared, so it's going to be negative 4 minus pi plus 2,400 over 8, 1 over 8. Well, may as well start from the beginning again. So 2, okay, assuming I didn't make any mistakes up to here.
I wanted to ask why we're sorry.
Don't worry.
Halving the radius, because shouldn't the radius like not change? Because I get it's half a semicircle, but isn't the radius already like going halfway?
So look, this is the radius, but x is this whole length. That's x.
Oh, x in the question. Oh, okay. Oh, okay.
So the
that's
radius would be half of that. That's why it's being split in half. So, okay, x 4 times. So multiply by 2, 1,200. Y equals 1,200 minus 2x minus pi x over 4. So 1,200 minus 2x minus pi x over 4 plus that, multiplied by x minus 2x squared, 8, multiplied top and bottom by 2, 2,400x minus 4x squared, this stuff happening over 8. Okay, then factor out minus 4 minus pi x squared plus 2,400x over 8. Take the derivative, so multiply 1/8. So it's just going to be plus the multiple times 2x plus 2400. Multiply the 2 ln -8 minus 2 pi x. Plus 2400 divided by 8, so -1x negative pi over 4x. 300 over here.
So what's the answer? Because I think I got the right answer. Yeah, okay, so I got the right answer. So what it did was that, from when you have the derivative, like 1/8, 2x.
This here?
Yeah, from there. So what I did was I just canceled out 1/8, because if you just multiply by 1/8, by 8 on both sides, the 8 cancels out. And then I just moved the 2,400 to the other side. And then multiply through with a negative.
2,000, so that means 2,400 over, wouldn't that be a negative answer though? Oh no, negative 2,400.
You should do it from the step like above that. The step you just showed me above that.
I'm just gonna check if I'll get the right answer doing that. Oh,
Yeah.
it doesn't give me exact divided answer divided by 600 over.
You know what I mean, right? Just move it to the other side.
Yeah. I think the mistake was before this, because if I were to do that, the answer would still be twice as big, which is our problem. So that means our answer.
This line is actually correct. So like if you take 2,400 to the other side, not this line, the line above that. When you say a apostrophe.
Yeah, this here.
So
the answer is actually 600 over pi plus 4.
Yeah, but the 1200 is right, I'm pretty sure, because that's your x value, and then you use that to find your y value, and then your y value is going to be 600 over pi plus 4.
I was reading the wrong number. We're right. We did over there. This is the correct thing. Okay. So 1200 over pi plus 4. Yes. So, okay, we're good. So this will be. I didn't actually get it. So let me 12. Oh yeah, no, I did get it. This is 1200. Just multiply top and bottom by 4. So it's going to be 1200 over pi plus 4. Okay, good. I was just reading the wrong thing on the solution here. That's why I thought it was wrong. So now we need to decide some bounds on our x value. So x value is at least 0, and it is at most 600. Right? At most 600. Because the parameter has to be less than 600. So x is between 0 and 600 inclusive. This is there. This is part of there. It's 2 times that much, so it's there. Now we have to decide determine the area if x was 0, the area if x was this, 1200 over pi plus 4, and the area at 600. So just looking at the picture, if x was 0, you'd have 0 area. Right? If this squished down to nothing. Similarly, if x expanded all the way to 600, nothing else would be able to be built. So area would also be 0. Great. Now let's check the area for this, right? So if the area equals if the x value is that, then the area would be I'll take this form. So I'm just going to plug it in. I'm not going to even bother with it. So bracket times bracket squared plus 2400 bracket over 8. So -4 minus pi times that thing. So 1200 over pi plus 4 plus 2400, 1200 over pi plus 4. So I got answer over 600 Okay, I got. Well, what does that mean? Oh yeah, that just means we got a number. That's the maximum area. But that's not even what the question was asking for. Sorry. Yeah. So the maximum area is 25,204.5. Oops, I'm not writing. Come on. Okay, restart OneNote. So the maximum area is 25,204.5. But sorry, again, that's not what they were asking for. So let's find the y value. That's what I was meant to find. So the y value would be, so our solution was 1200 over pi plus 4. So the y value in that case would be 1200 minus 2 times bracket minus pi times bracket over 4. And 1200 over pi plus 4. 1200 over pi plus 4. So I got, yeah, some decimal, but it's the right decimal. So 84.02, right? Which is the same as the answer, I'm going to assume, minus 600 over pi plus 4. Yes. Okay. So that is the same decimal as the answer, just not in exact form. If you wanted to do exact form, just put this in and do some rearranging algebraically. I'd prefer not to. But so that is the right answer. So that's the y value of the maximum. And the x value of the maximum is that. The maximum area, sorry. The x value to maximize the area is that, and the y value to maximize the area is that. So there you go. And that's the last question. That's the last question. So, I guess that's all that I have planned for now. So, unless anybody else has any other questions, then that's about it for the stream today. So yeah, so just let me know if you have any questions. Anything from the textbook or anything like that, I can still help. But yeah, other than that, well, I mean, good luck everybody on the test tomorrow, 3 o'clock, I think. I hope, if I have that right.
Yeah, it's 3.
Yeah.
Thanks again for that.
And I hope.
That's the one thing I don't know. Well, there's many things I don't know, but one of the things I don't know is what time is
One
the
of the
test.
major things.
Yeah.
You ought to know.
Exactly.
Good luck, everybody.
Yeah, good luck.
Good
everybody.
luck.
Good luck. Hope it goes well.
Thanks again for
Right.
going stuff.
Of course.